Welcome to the Explainer. Today, we're going to break down the architecture of the Wireless Application Protocol, or WAP. This is the tech that first got the internet onto our phones. And really, to get how far we've come, you've got to understand how it was all put together back then.
All right, before we really get into the weeds, let's just take a look at the big picture, the WAP architecture itself. Now, at first glance, it looks like a layered stack, kind of like the internet protocol we all know. But here's the kicker. Every single layer was rethought from the ground up, specifically for those early mobile phones. We're talking tiny screens, crazy low bandwidth, and connections that were, well, let's just say laggy is putting it mild.
So here's how we're going to tackle this. We're going to build this thing from the ground up. We'll start with the basic architecture, then hit the transport layer, talk about security, then sessions and applications, and finally, we'll see how all these pieces actually fit together. Okay, let's get into it. The main goal of WAP, right, was to get internet content onto phones. Simple enough. But the really brilliant part was how they did it. It was built to be totally independent of the wireless network. It didn't matter if your phone used GSM or CDMA, and believe me, those were the big rivals back then. WAP was designed to just work on top of whatever you had. And it all starts right here, at the very bottom, with something called bearer services. This is the foundation, the bedrock. Think of these as the actual radio waves, the different wireless networks that physically carry the data from your phone out into the world. You can think of these bearers as different kinds of highways, right? Some were bumpy dirt roads. Others were maybe single-lane pavement. WAP had to be like an all-terrain vehicle that could handle any of them. So whether the data was piggybacking on an SMS text message or using an early data network like GPRS, WAP didn't care. It was built to just float on top and create this one universal platform. Okay, next up, the transport layer. So we've got all these different networks at the bottom. The job of this next layer is to basically create one single consistent data service that everything else can build on. And this is where the Wireless Datagram Protocol, or WDP, comes into play. You can think of it as a universal translator. It's an adaptation layer that gives all the layers above it one common way to talk, no matter how chaotic and different the actual networks are underneath. And this is the key takeaway, really. WDP is what makes all the higher levels completely, and I mean completely independent of the network below. And that was a game changer. It meant developers could write one WAP application and it would just work. They didn't have to worry about all the nitty-gritty details of the network. WDP took care of all that messy stuff. So yeah, it basically just smooths everything out. It papers over all the cracks and differences between the networks. By giving everyone this one consistent interface, it means the rest of the WAP stack only needs to learn one language, WP's language. All right, so we've got a consistent way to move data around. What's next? Well, we've got to make it secure and reliable. I mean, this was absolutely non-negotiable, especially if you wanted to do anything like mobile banking or shopping, even in the early days. And this brings us to the Wireless Transport Layer Security, or WTLS. This layer is a perfect example of how WAP was built for mobile. It's basically WAP's version of the SSL or TLS that secures the regular internet, but it was completely re-engineered for wireless. So, WTLS handles all the important stuff. Data integrity, so you know your data hasn't been messed with, privacy using encryption, and authentication. But, and this is important, they didn't just copy the internet security protocol. No way. They rebuilt it to be super lightweight, using less of your phone's processor and sending fewer messages back and forth. That was absolutely critical for saving battery and just making things work on those slow networks. Okay, so with security in place, the next layer up is the Wireless Transaction Protocol, WTP. Now, don't think of this as just a continuous stream of data. WTP is all about managing transactions. You know, that simple back and forth, I ask for a web page, you give me the web page. And this thing was designed to be incredibly efficient for that request-response dance of mobile browsing. Here's a good way to think about it. TCP on the regular internet is like a massive, reliable semi-truck. It gets the job done, but there's a lot of overhead. WTP, on the other hand, is more like a nimble delivery drone. It's lightweight, it's fast, and it was perfect for those shaky, slow wireless connections where literally every bit of data was precious. Okay, so we've got secure transactions down. Now we can climb higher up the stack and start talking about managing user sessions and the apps themselves. This is where things start to feel a lot closer to what you, the user, would actually see and do. So let's look at the Wireless Session Protocol, or WSP.
Its whole purpose in life is to create, manage, and then end a session between your phone and the server. It's kind of like making a phone call. You establish the connection, you talk for a while, and then you hang up. But WSP did more than just the basics. It had some really cool features built just for mobile users, and probably the most important one was the ability to suspend and resume a session. Think about it. What happens if you're browsing and a phone call comes in? WSP could pause everything, let you take the call, and then pick up right where you left off. That was a huge deal for making the experience feel less fragile.
And here we are at the very top of the stack. This is the Wireless Application Environment, the WAE. This is the big one. It's the layer that your phone's apps, like that tiny little web browser, would actually talk to.
Yeah, this is really where the rubber meets the road for the user. The WAE is the whole sandbox where mobile apps lived and breathed. It laid out all the tools for developers, things like a special coding language called WML, which you can just think of as a stripped-down, lightweight version of HTML, and even a little scripting language to add some basic interactive bits to the page.
Okay, let's recap. We've built the whole stack, from the physical network all the way up to the application layer. But the big question remains. How did all these pieces work together to take a huge, sprawling web page from the real internet and cram it onto that tiny little phone screen? That really is the million-dollar question. The normal internet was just way too big and bloated for these little devices. The secret sauce was a combination of translation and some really aggressive optimization. And it was all handled by one critical piece in the middle. Here's how it worked, and it was actually pretty clever. You have this thing called a WAP gateway that acts as a middleman between your phone and the big wide internet. It would grab a normal, heavy HTML web page, translate it into that super light WML we talked about, and then, and this was the master stroke, it would crunch that WML down into a super compact binary format. Sending ones and zeros instead of plain text saved a ton of bandwidth. It made the whole thing possible. And that really brings us to the big takeaway here. Look, WAP itself is ancient history now, right? But its whole philosophy, this layered approach of separating concerns, of securing data, and especially of optimizing content like crazy for mobile, that was the blueprint. It was basically the set of training wheels for the powerful, super fast mobile internet that we pretty much take for granted today. So it makes you wonder, doesn't it? What were the biggest lessons we learned from this early attempt that are still with us now?